Here's another example. According to Gallup, about 33% of Americans polled said that they frequently experience stress in their daily lives. Suppose you are in a class of 45 students. What is the probability that no more than 26% of the class will say that they frequently experience stress in their daily lives? So to think about this, is this a two-sided situation? And it is. We're going to classify people as experiencing stress frequently or not experiencing stress frequently. Do we have a fixed number that we're looking at? We do, 45 students. Is this from a simple random sample? Well, that's the part that may be a little suspect here. We're going to have to make an assumption that our 45 students in our class represent a nice assortment and random sample of Americans. That we're going to have to kind of live with that in this. It's not ideal, but we will definitely have to assume that in order to make this example go forward. Now, the 33% we see here that Gallup determined, we're going to trust as our population proportion, that is of all Americans. Now, the 26% that's mentioned second is going to be the proportion from our sample, that is our sample of 45 students. Let me show you how this fits into the model. Again, a success is experiencing stress frequently. Again, doesn't sound like much of a successful thing, but if that's what we're interested in finding the probability of, thus it becomes our quote-unquote success. P, the population proportion, is 0.33. Thus Q, which is the complement of P, is 0.67. In other words, 67% of Americans do not experience stress frequently. N is 45, that's our sample size, and P hat is 0.26. That's the proportion we're curious about in our class of 45 students. Now, this is a sampling distribution of proportions. It will center itself around P, our population proportion, at 0.33. We'll take that same P and plug it into the standard deviation formula, 0.33 times 0.67 divided by the sample size. Lastly, take the square root of that, and we discover that the standard deviation for this sampling distribution is 0.07. Notice the 0.07 are the tick marks here, exactly spaced out by the standard deviation as we've done in other modules. And P hat, the 0.26, the sample proportion we're interested in, falls right there at one tick mark to the left of our mean. So what we want to do, we want to figure out what is the area under the curve here. That is our probability, the probability that no more than, in other words, don't exceed 0.26, no more than 26% experience stress. Well, we have to figure out how far away P hat is from P. And we can do that with a z-score. If we subtract the two values, divide by the standard deviation, we can see that our z is equal to -1. Our next step is to look -1 up in our z-table. When we look it up, we determine that the value is 0.1587. Again, area to the left, a quick read from the z-table. Thus, there is a 15.87% chance that no more than 26% of your class will experience stress frequently. So sort of a part B of this question. If 44% of students in the class said that they experience stress frequently, would you be surprised? So this is the same model as before. I can reuse it, centered at 0.33. Same standard deviation. Our sample size is still 45. So on the model, I just placed in roughly where I believe 0.44 would land. You can see that it is only 1 and a partial standard deviation away, not quite 2. We can figure out exactly how many standard deviations away it is by computing a quick z. 0.44 minus the mean of 0.33 divided by 0.07 is 1.57 standard deviations. Since our z is not more than 2, then we will say this is not unusual. would not be unusual to observe 44% of your class saying that they frequently experience stress.